Welcome back, everybody. I'm not in charge today, but I wanted to ask you my favorite question. Anyone remember what my favorite question is? Yeah, somebody's saying that. Who remembers? What's my favorite question I start classes with? What did we do last time? Hey, you're cheating. That's right, she took my other class. Okay, so what stands out from last time? What was noteworthy, important, interesting, unusual?
It was about developing two statements and I said, why should we tell something to students and ask?
Right, ask rather than telling them. Pretty cool. That's something we did. Teaching statement, ask, don't tell. What else?
3 levels of course contents. For example, what are essential, what are the core in the course, what are important, and what are nice to know.
Right, yeah. So making the distinction between the essential core, what's important, and then what's just nice to know. And I had you guys think about that with your notes from the week before. Absolutely. Are they trying to talk or are they just?
No, I can't get them to mute their mics.
And based on what I went that, like after we did that, we wrote it on the whiteboard, and then so it kind of elicits some more clarification for us to see what was important, and then kind of approve, show us that you approve what we were saying, and then least most important, least important, but they all overlap.
Mm-hmm. So we put it up on the, Al typed up your responses, we put it on the whiteboard, and we had a discussion of the use of whiteboards. And it was a way to see what was going on. Absolutely. And there was a lot of overlap. What else?
Changes your goal each.
Uh-huh. Yeah, but the fact that you can adjust on the fly as you go. Go with what's in front of you. If it's not working, try something else. And yeah, you don't have to be rigidly locked into what you thought you were going to do. How you start the class is important to get everybody on the same page, absolutely.
Teaching style. Everybody have their own teaching style.
Mm-hmm. Everybody has their own. If you're not a stand-up comic, naturally, don't try stand-up comedy in class. Unless you really want to stretch and grow, that might work.
Usually doesn't work.
Okay, well, you might remember the German commercials. There was a commercials about the Germans. Like, I think it was a Foster's commercial. It's not a German trying to do stand-up comedy.
Yeah.
It was very offensive to you, I'm sure. All right, one last thing. Who's got one more? Last time. We sat in this room. Some of us had lunch afterward. Who's got one more? I know we have more questions.
I love the attention span side of things.
Uh-huh.
20 minutes. Don't do one losers.
Attention span. Yeah, exactly. All right, you're off the hook. We'll get started for the rest of today. We've got a couple of guests. Brady, you want to introduce them with what we're doing? Oh wait, one more thing. We talked about teaching philosophy, and I went back and found my teaching philosophy statement from when I was applying for jobs, from when I went up for tenure, and then for 2 teaching awards that I was nominated for, and then modified it to do the outline if I was going to revise it again, what I would say. I didn't bother to write up the full one again, but the outline for how I would revise it. That was posted on the site as an evolution of teaching philosophy. I just thought you might be interested to see how a single philosophy might change over time or might apply to different circumstances. It's mine, so it's not necessarily going to be exactly what you would write, obviously. But the ideas I thought might be helpful. And then there's other examples that I don't know if they're posted yet or not, but there will be other examples of other people's teaching philosophies. They've given us permission to share them with you, just so you see some examples. But I did find all those older ones of mine as well, and I thought that might be an interesting way to look at it. I wasn't brave enough to read each of them in detail to see how they've changed. But that's up there if you're interested. Okay, take a break.
So before I forget, a couple of logistical things. If all goes well, we will be in a different building next week. We'll be in the microbiology building. I can't remember the room number now.
What is it, Monica?
What is it? 1044. It's in the front part of the microbiology building. They've been remodeling that room. They're supposed to be done. Right now, that's where we're planning on being. So unless you hear differently, that's where we'll be next week. Now, I'm very fortunate today. We're very fortunate, and we're actually kind of beginning a different phase in Teachers College. Up to this point, you've just heard from us. But now we're going to be bringing in at different points outside experts to give a different perspective. We're very fortunate enough today to have two folks that I hope you guys will enjoy. I know you guys will enjoy hearing what they say, to kind of think about what it means to kind of mentor and work with teaching assistants, but also what's it mean to work and teach in laboratory settings, which many of you guys will do. And both of these folks have a lot of experience in that. Dr. Monica Ali's in microbiology and cell science and supervises, how many lab sections do you supervise? A bunch. She supervises the intro labs, and she's got hundreds of students coming through her labs with dozens of TAs coordinating that. So she's got lots of experience. And then Dr. Mike Kane is in environmental horticulture and does an excellent job teaching in his own laboratory and integrating his students into the things that he does. Now, both of our guests are very open to questions and discussion, and so by all means, if you've got questions for them, now's the chance to pick their brains and gain their perspectives. So I think, Monica, you're going to go first, right? So I will pass the mic to you.
And then certainly, Monica, to repeat the question so they can hear.
Okay.
Okay. So you can, if you clip it on or whatever, that'd be great. Yeah. Every day is an adventure with our technology.
Tell me about it. All right. So I think I'd probably start off saying that a lot of these people have been really inspiring to me, and Dr. Kane as well. When I started teaching here, I took the Teachers College, and it was one of the best things I've done because I hadn't taught for a long time before I started teaching. But as you're all postdocs, let me just fill you in where I was when I was in your shoes. So I had been at the University in Germany and in Britain. I got a bachelor's degree from the University of Edinburgh, Scotland. And then I moved to the States with my husband, went to Mississippi, got a master's PhD, came to UF as a postdoc. And I did my postdoc here. And then I had, the options, what do you do after postdoc? That's probably a lot of you have the same question. And my husband was a young faculty at that time. And he was trying to go through tenure. And it was very, very stressful. And we had two kids. One was 2 and one was 12. And I thought, two of us going through the tenure process, it's just not what I can imagine. Maybe later. And then after I did my postdoc for 3 years at the University of Florida in oral biology, I got the opportunity to work with a small startup company. And some of the folks over there, they started a company called Benny Biomarkers, and it was just a new idea. They had all the patents, part of the patents. And they were out in Alacha where we have a small incubator. And I needed somebody to start off their R&D, research and development. And then within a couple of weeks, they hired me. And they showed me an empty lab and said, so set up the lab and do research for the company. And I have, just like you, probably educated at the university, always been very safe and good environment and not too worried about anything. I mean, never talked to a CEO or what a patent was, and none of these ideas. And then I got to work at the company, and I realized with a very, very short amount of time, I had no skills to survive in the real world. I mean, I didn't know how to file a patent or how to get business grants or how to deal with all the money parts. And so I had a very steep learning curve, and I really, really enjoyed being in that environment. And a couple of reasons. One is really applied. So we were establishing ELISA assays for brain biomarkers, and it was really a new territory and really important work. And there was a goal. It wasn't just like doing research in another Western blot or another ELISA, but there was a real goal and a real product at the end. And I enjoyed that. And I also enjoyed the pace because it was just really driven. We had to have deadlines, we need to get products, we need to get stuff to the market. And so it was a very good environment. I stayed there for 7 years, and during that time I realized that, again, these skills I learned during my scientific education are not sufficient for me to be really effective in the real world. So I went back to the University of Florida and got a Master's of Entrepreneurship, where Dr. Uesaki was one of my outstanding teachers. And it was really, really important skills I learned during that time. And although I'm not in the entrepreneurial field now, I realize that I use a lot of the skills what I'm doing during teaching. I still use that what I've learned during my business education. I'm back at the University of Florida. And so I had a full-time job, I had 2 kids, looked after a husband who was going through tenure and was going to school. So I was really busy, but working hard is always good. And learning new skills, I think, is one of the most important things I can recommend to all of you. Anyway, that's just my background. I came back to the University of Florida almost 3 years ago, and there was a teaching position open in microbiology for labs. I love microbiology. I did a master's in microbiology. I did my PhD in parasitology. And so the field was really, I'm very, very passionate about it, which is, again, one of the important things, I think, being a good teacher is to really enjoy what you're doing. I was hired December 12th and started teaching January 7th. So there wasn't a lot of time in terms of transitioning and getting used to it. And the last time I taught before that was 15 years ago during my master's in Mississippi. So I really hadn't done a lot of formal education and teaching or anything else, but somehow it worked out all right. So the labs, large labs. We have between 700 and 800 students a semester. And we teach from Monday morning until Saturday at lunch. So we teach 7 days, 6 days a week. I have about 50 undergraduate PAs a week. But it's a lot of fun. And the key thing is really to get the student feedback and realize that what they enjoy, what they learn, what skills they get for their future careers, and that makes it all worthwhile. So how we changed it. So the lab, when I got there was somebody in the same position for 33 years. And she did the same syllabus as the people did 20 years before she started. So the syllabus was about 50 years old, and it really hadn't changed much. And I thought, it's going to work because things are not done the same way anymore in the lab. Technology has changed, people have changed. And so we scrapped, after one semester, we scrapped the whole syllabus and started from square one. And the key thing is really to surround yourself with people who are motivated and who are good and who are great to provide feedback. A lot of the feedback I got was really from my students. I said, what do you want to learn? What are you interested in? And so understanding what their majors were, what their interests were, what their fears or obstacles were, what they've learned before. I assumed a lot of things which a lot of them didn't materialize. I assumed that everybody knows how to draw a graph on Excel, in their third and fourth year. That wasn't the case. And so we added a lot of things that I think the students need to know as they leave the university and go into the next step of life. So we started our curriculum from the very beginning and built it really very student and real life centered. And I think that's another important thing is that if students can identify with the material they're learning, they are much more active learners and much more interested in learning because they can identify themselves and see how they can use it later on in their careers. We have a lot of, probably about 80% of our students are pre-professionals and pre-healthcare. So I see a lot of, nursing, physicians, pre-physicians, dentists, and so on. So we geared our syllabus a lot towards, the health-related current topics. One of the key aspects to having been successful, I think, in my position was that I had a very supportive boss. And I came up with all these lots and lots of ideas and said, just try it out. If it doesn't work, change it the next semester. And that was really amazing support because a lot of times they say, oh, don't do that because you don't know. Or you're in a teaching team and not everybody's in the same place. So it's very difficult sometimes. But I was in a very lucky position that I had all the support and I could really try pretty much anything. And we did. Most of the things worked and then some things that didn't work, we changed. And so it was a very great opportunity for me to really realize and incorporate things what I've learned from the different avenues in my career, in my life where I've been. And so it's been a lot of fun. I think labs are absolutely important in education, and as we move more towards the online learning and distance learning, all this stuff, I think labs are probably the most crucial factor for anybody to make a difference later on, because you can't learn these skills online. And even if we do it in a condensed version or in different forms, but the hands-on part is just important. I mean, computer skills, bioinformatics, some things can be learned online, and we have a hybrid version of the lab now, where parts can be taught online, but some stuff just has to be done in person. One of the interesting parts of our project is, so I divided up the semester in two halves. The first half is just learning skills. So they come in and learn these skills in an interesting way, but it's just skill-based microbiology, streaking, plating, aseptic techniques, diagnosis, PCR, DNA extraction, and so on. And then the second half, then they have a midterm. They get tested on all the skills they have learned. And we get some tears during the midterms, and they're a little bit upset at times. But we try to set our goals high, because they're really proud when they actually accomplish what we set out to do. And then the second part of the semester is about their research project. We do smaller modules each class, but the main part is their research project. And so they really come up with their own ideas. So we talk about current problems in the first half of the semester, and then they learn all the skills, and then the second half of the semester, they actually use these skills. They go into the literature, write a small proposal, and really do something what they're passionate and interested about. And we had all sorts of different projects, from a horseback rider who was MRSA positive as a carrier, and she was checking out her horse, and the horse was positive as well. I had a farrier who was working on hoof infections in horses, and he was growing the organism and had controls, and healthy horses and non-healthy horses. And we had all sorts of different projects, and they were really, really interesting. And sometimes they come up with ideas I hadn't thought about, I didn't know about it. So I really learned from my students during these projects. And what's the most exciting part is when they take ownership. When you talk to them and they say, oh, I read this in this paper, or I came across this article, or this is my project. And this is really exciting to see students at that age take ownership and be excited, and not just sit there and memorize and listen to you during a lecture. And so it's been really exciting to teach. I'm really enjoying it. It's sometimes a little bit overwhelming, because we have so many people, and I think my largest problem is really getting the teaching assistants up to speed. Because we have teaching assistants, they come fresh from different countries, or they just graduated with the bachelor's, and our students teach in their first and second semester. And so they just graduated with their bachelor's, they just started graduate school, they've never taught before in most cases. A lot of times they haven't learned the material. And so for them, they have to take classes, they have to rotate in the lab and teach. So it's very, very challenging for them. But we try to be a real supportive team teaching, develop a team teaching network. So if they have any problems, we meet every week, we talk about problems encountered, student issues, and so on. So we really try to work together and build a team where everybody feels comfortable. We do damage control if we have a TA who really doesn't live up to the expectations, and that happens. But usually, things work out pretty well, and after a short amount of time, the TAs become very confident. One thing what I do not do is micromanage. They have the material, we do TA meeting, but then I leave them alone. I give them feedback if they need to, but I do not just micromanage them and tell them what to do. So they have a lot of leeway. They get the modules, but then they develop their own classes around it. So the way they want to present it, the way they want to give quizzes, the way they want to include technology, it's entirely up to them. As long as they teach the basic core, they can teach it any way they want. And most of them do appreciate it. Again, it's a bit more scary because it's easier if you do what you're told to do. But I think for the teaching experience, it's a much better way that they can actually figure out, how do I teach? What's my teaching style, rather than being told what to teach. And I think that's pretty much everything. So we're doing a TA training. We have another thing what we've done with the help of our funding, our local funding, is we developed a lot of videos. So a lot of the techniques what we teach in lab, we have now on video, and so it's available for everybody. We use a lot of technology as well. And we will have a TA training camp probably starting next summer, where we get the TAs in all a week before, and then walk them through all the exercises, because it's just a little bit less scary and they're more prepared. And I think it's going to help a lot. With the labs, again, we also teach distance. We have had the labs at one REC and at Miami-Dade Community College, so we ship out the materials and train the TAs there. And then we had last summer, for the first time, we did an immersion lab. And that was a really interesting experience. So our distance students came to campus, and within 11 days, we taught a whole semester worth of microbiology. So we started at 8 in the morning and usually went up to 5, every evening. And it was a really good experience because the students weren't distracted. They were really focused. And in microbiology, you see something every day because, things grow overnight. So that was a really good experience, and I think they got a lot out of it. We did field trips, we did all sorts of active learning games, we did presentations, we did the projects. So we really tried to make it interactive for the students and make it fun. And yeah, I hope we will grow our program with distance education. I think we'll probably go into more of the RECs and more distant sites. We'll teach there, and I personally think everybody should take microbiology in the first year because it's so important, but I'm waiting for this to put them away. All right, any questions?
I have a question. So you mentioned that you do distance learning at university.
Community college, North Campus.
So the campus do distance learning in the University of Florida.
Yep.
So what is it?
So we started our 2+2 program. So when you get an AA at Miami-Dade, and now at all other community colleges, you can start taking online classes. And we taught our lab there for the first time when we started the program. So our micro lab from UF was taught at Miami-Dade with a local instructor, but all our curriculum. And so we're trying, again, one of the reasons why we do, the distance ed and outreach, we also have a STEP grant where we really try to reach minorities and underrepresented students and really bring them into the STEM field, which is very important. And I think if they don't come here, we go there and make sure they get the education they would get if they are.
So the local instructor is employed by UF or just by Miami-Dade?
We hired an instructor at Miami-Dade. So she was teaching there, but she was part-time teaching us. It was a really good experience, and people were really super funny. Their labs down there are amazing. Are you from there?
Yeah, I'm from Barbados originally. But I've been by myself.
So a lot of the community colleges, their equipment and their labs are amazing. I mean, they're oftentimes better equipped than what we have at UF, which is what it is.
You mentioned how you worked in industry for skills that you bring from industry into teaching. I mean, maybe I could see that maybe students are going to go into industry. Is that what?
Well, the skills, what I'm bringing back, I think there's a lot of it is the management part. Just the general awareness that science doesn't exist in isolation. Benchwork alone doesn't make a difference in the world. You have to know about grants, you have to know about patents, you have to know about regulations, you have to know about clinical trials, and all these different aspects to really make a difference. And so I'm trying to tie all these parts into my curriculum and teach the students that what they learn is good, but then there's still all the other things as well. And then the second part, what I've brought back from industry into UF is I'm teaching a careers class. And so, because a lot of the students really don't know, I mean, in undergraduate degree in science, that's all you learn. And so we developed a career seminar, we're teaching it right now for the third time, and we get speakers from all over the place. From the FDA, from Procter & Gamble, we get somebody from Sherwin-Williams, we get somebody from the food industry, like a whole variety of things so that people actually realize, there are lots of jobs out there. You don't have to stay in academia. And again, a lot of traditional academicians are still, oh, you can't go to industry because they're bad. I don't know what it is. But it's just the way the mentality is. It's our culture. And I'm sure some of you have heard that before. Don't go to industry. But it has changed a lot. When I started in my master's and postdoc, funding rates were at 40% from the NIH. So every other grant you send off usually gets funded. Now it's at 8%. It's really difficult to maintain your faculty position at a university. And there are great opportunities at companies out You know, they need people who are really highly trained and motivated and skilled. So I personally, you know, I think that just lots of opportunities, whatever is the right thing for you personally, is the way you should take. But a lot of students don't get the vision that there are other opportunities out there. What not?
It's on the same type of question. When you went to industry, you said that you were lacking some skills. So what kind of skills, if you remember?
I felt so lost. I mean, I just, you know, growing up in a lab, doing experiments all day in and out, and I've just never realized how industry works, how business works, what the budget is, how it's important to look after the money and the grants, the different funding sources. You know, working with business people who speak a different language, and you have to communicate your information, whether it's data or ideas or, you know, you're requesting budget, you have to communicate in a different language. So giving up and giving a scientific talk, there's like, it goes straight over their head. But you have to sort of decipher it and give it to them the way they need to hear it. And then they can, you know, pitch to politicians to get more money. That was one thing. The other one was patents. You know, I had no idea what a patent was. I may have heard the term before, but I didn't know the logistics, how it works, when you file patents, how, you know, how long it takes, how much money it costs. And so I was working with a patent attorney for about 3 years and really learned a lot about that as well, because it's an important part. And, you know, the sooner you know about it, if you have a really good idea and come up with something, you know, think about, you know, putting a patent together, protect it. How do you keep your lab notebook? So there are a lot of little things that needs to be done beforehand, and oftentimes it's too late later on. Because if you haven't written down the right notes, if you haven't done all these things, you may or may not get a patent. So I think there's a lot of important things. What um, I felt like I had no idea. And it was after 30 years of education. But it was an interesting experience, and I really enjoyed learning more things.
I have one more question. So you mentioned business grant. How is it different to, I guess, grant for research? I don't know. Like, I've never written a business grant, but I know in my lab I do some grant proposals for, like, you know, funding for research. But then how is it different to a business grant? I don't know if you did about business grants.
I did both. And so the business grants are really more in terms of products, so the SBR, small business initiatives, and the funding rate is much higher, so they're about 20%, which is much better to get, or much easier to get. And it's really about the delivery. You know, what can you deliver and how can you get it to the market, rather than I've got this great idea and I'm solving a problem. You know, we don't know where it's going to go. So it's really the application is one of the main differences. That's really, and you usually budget more money for other things like patents, you know, administrative. The budget is quite different.
So do they have like call for proposals too, like how they have it for academia? They'll have a call for proposal, and then you see like the scope of the grant. Is it the same kind of like format to as well?
It's the same idea. And then the review process, review process has a little bit more, a different composition of people, because they have more business people in there as well to actually review the question and look for business merits. Right?
So, just to repeat that, you don't need this syllabus courses, and it is based mostly based on these skills.
A lot of it, yeah.
The student doesn't have to really realize how can we the courses we have the experience.
Right. I think it's more like the perspective in so, for example, if they want to be physicians or dentists or, you know, other healthcare workers, and tie in current topics from that. Some are interested in, you know, parasites, and some are interested in different areas. But we sort of take the base idea and elevate it up to the next level, because they do not have the vision and the experience. But then some they read and they come up with something and they've heard about something. So a lot of them work in labs, and so they, you know, come up with certain ideas.
Monica, so I suspect many of these folks will be in faculty positions and will run labs at some point, both teaching labs and research labs. So what, if a brand new faculty member is hired in micro and said, Monica, I need to get started developing my lab. Where do I begin? What's that piece of advice you give?
Teaching lab or?
Why don't we start with teaching lab first?
Come up with something that's exciting and interesting, and not just what, something that can resonate with the students. Try it out. If it doesn't work, give the students extra credit. If things don't work out all the time. But they're really worried about their grade, right? They're all worried about their grade and understand why. So if things don't work out, don't blame them for it. Don't put ever blame on the students. It's our responsibility to make it work. And so, we've done a lot the first couple of semesters is, that didn't work, but, we'll try something else. And the students are usually, if you're honest with your students and get feedback, they're really very, very understanding. I think an important part is to get good equipment. Get top of the line equipment, see if you can get any internal funding, because there's no point in teaching students on outdated equipment that people don't use anymore in the lab. They can't teach the skills if they don't use it anymore in the labs. So we were very lucky to get a lot of good equipment. And so our students from the department come back, graduate students, and use the equipment in the teaching lab because it's better than a lot of in the research labs. Yeah, and just be patient, and it takes a lot of time. And don't lecture too much. We just had a new person taking over a lab for us, and he has a 3-hour lab block and lectures for an hour. I record the lectures before and let them listen to something. So the second semester is a project in smaller modules. So we still teach them something every week, but it's much shorter.
That's the pros and cons of it. Because your students have so I'll think of how you can use the manuscripts in your classes.
Right. I mean, they come in packages of 36. So the TAs are in charge of it. They have a small proposal, and then it's really the merit. Did they follow scientific method? Do they have literature? Have they read the papers? Did they make sense out of the data? Did they analyze the data? How do they present? They all make posters. Does the poster look good? So there's a lot of criteria. We've got a good matrix on how to grade that. And I do a lot of peer grading in that kind as well. So I give all the other students, grading sheets, and they grade each other. They usually do it. They come up with all sorts of things. Right. Sorry I've taken so much of your time.
Oh, you can take mine.
But I think, and so what we do works for, the large labs and, really get the students involved. And I think what Dr. Kane does, bringing his research into the labs, absolutely phenomenal. And I think I'm really surprised that a lot more people don't do it that way, because you're excited about the work you do for your research, and the students can help. I mean, I hope I would do some more research over the next couple of years, and if I have, 700 hands a semester, I get a lot of data. So, from that point of view, and I think everybody who teaches should bring their interest into the research, into the teaching lab, because there's a lot of people nowadays. A few more people who actually bring their labs and then publish with their students. I mean, our department head, Dr. Trippett, they sequenced the alligator genome in his genome sequencing class, and he published several papers on that as well. So there are lots of ways of integrating new research into teaching. It usually works. And he's just, again, my great role model when I was in Teachers College.
So why don't we go ahead and take our break as we're transitioning? And so let's take about 10 minutes. We'll reconvene in 10 minutes, and then we'll hear from you for a moment.
Let me try something here, guys. I may have to shut it down and turn it back on. Yes, I have it. Supposedly.
I haven't.
Okay, good.
I left my jump drive home. Luckily, I had submitted it via email.
Okay, you can hear me right now, but when I switch, Can you hear me now, or did I disappear?
We can hear you, but it's not clear.
How about, yeah, so let me shut it. It's not grabbing. I'm going to shut down my computer and turn it back on, so you'll have to log in again.
Okay. Okay.